Hey everybody and welcome. Today we're going to be talking about expected value. So basically the goal of this video is to put together a lot of things that we've been working on and kind of base a class just in the application of the probability that we've been doing. Because I think a fair question is a lot of these calculations are pretty tricky and really hard to figure out which formula we should use and all this stuff. And at the end of the day, it's like, why are we doing this? So expected value is actually, I think, a pretty good answer to that question. So let's start off by defining it. So the expected value is a predicted value of a variable, and it's the sum of all possible outcomes multiplied by how likely they are to occur. So the idea here is we're applying this to more or less money. And we're going to take individual events, tie a monetary value to them, and based off of that predict, is this a good or is this a bad idea? So some examples that we can go through, and I think it's easiest to talk about what this means through the world of an example. So say you enter a casino, and upon deciding which game to play, you choose a game where the probability that you win $5, you calculate out to be 0.3, and the probability that you lose $2, you calculate out to be 0.7. And you're trying to decide, is this a good idea? Well, it's a good idea if you make money, if you're a rational person. It's a bad idea to lose money. So based off of that, let's see, do we expect to make money? And you might look at this and say, more often than not, I'm going to lose, so automatically I should not play this game. But there are things that make it more complicated. It's not exactly 50-50. You win more than you lose in this case, so there's a lot of things that go into this type of game. So first things first, how do we do this? Well, if we look back to our definition, it's telling us that we are taking our possible outcomes and then multiplying them by how likely they are to occur, which is a really fancy way of saying probability. So if we win $5, we're going to multiply that by its probability. And if we lose $2, which is a negative value, we can also multiply that by its probability. So here, we expect to win about $1.50, and here we expect to lose about $1.40. You're like, where did you get that? 5 times 0.3 is 1.5, 2 times 0.7 is 1.4. So on average, if you play this game 1,000 times, you'll expect to win about 10 cents every time you play. And that's how people actually go ahead and they make money at things like being a professional gambler, is they know if they play a game like this, they might lose $2 a whole lot of times, but if they play it hundreds of times a day, they expect to make about 10 cents on average every time they play. So you win some, you lose some, you might have better days than others, but if you do this for an entire year, take the amount of money you make, divide it by the number of games you played, and you should get about 10 cents every time. And this math is actually pretty close to being perfect in reality. If you can find the actual probabilities, this will be true over the long term. This is also why I get frustrated and why I don't gamble basically anything. Because when I do go, I've gone probably like 2 or 3 times in my life. I always start off with just a few dollars, and then I basically calculate the probabilities of what I should or shouldn't make. And then after so many times of losing, I kind of come to the realization, and I actually do this out on a napkin or a piece of scratch paper on the side. I'm like, well, there was a 0.00000% chance of what just happened to me happening in real life. So maybe this casino is rigged. Maybe they're just here to make money. And then it dawns on you, yep, that's how they stay in business, to make your money. So again, an application in the real world of kind of how this stuff actually works. So let's do a second example here of expected value. And again, a similar context here of basically, is this a good idea? So a new game, this game is the probability that you win $10,000 is not even 1%. And the probability that you lose $10 is basically all of the other percents. And this is probably a pretty standard gas station lottery type game. If you're like, oh, I might win a couple $1,000s, but you have to pay $10 for the ticket. And if you ever noticed, usually the higher the prize, the more you have to pay in. So is it a good idea to buy a ticket where you have a very low chance of winning, but if you do win, you win a whole lot of money, or basically just don't buy it? Are you wasting money if you do this over and over and over again? So let's see. So $10,000 times our probability of 0.0001 gets us $1 expected earnings every time we play, and then losing $10 is negative 10 times 0.49, which is losing. It actually rounds up to $10. So you honestly expect to lose just about $10 every time you play. So it's like $9.99. So we do have to round up there. So every time we play this game, on average, we expect to lose $9. So this is an example of a lottery type game. Is not a game that you would want to play over and over and over again, say every day for the rest of your life, because on average, you're giving away $9 every time you play that game. So if you're a professional gambler and you want to do this for a living and actually make money, you're not going to buy that ticket. And you can actually get a reasonably good idea of the odds of winning the lottery if you just look up the statistics on how many people buy a ticket for this game. What is the average payout for this game? And you can do the expected value. And again, like I said, this top problem, if you do it and you have any money to make, if you do it a whole lot of times, you reduce your risk and you're pretty certain to make that money. If you expect to lose a whole lot of money, you better be comfortable just giving your money away, or as you walk into the gas station to buy the ticket, you might as well just throw it on the trash can, because you're going to have basically the same outcome. So a good application of probability and how it applies. So for the first set of questions, we're just going to practice basically determining, is this or is this not a good idea? In the second set,